Good morning, children. So let us move on to the next question, question number 19. And question number 19 says, ABC is a right angle triangle of given area S. Find the sides of the triangle for which the area of the circumscribed circle is least. So we have got a right angle triangle ABC whose area is S. So S is constant over here, fixed. And we got to find the sides of the triangle, that ABC, so that the circle that you're going to draw outside that triangle should be of least area. Okay, so here we are talking about least area of the circle. Okay, so that means I have to write the expression for the area of circle in terms of a single variable. Okay, so let us see. So here I have taken right angle triangle ACB. Okay, here right angle is at C and circle is drawn. So when you are drawing circle, okay, on a right angle triangle, so in that case the hypotenuse is the diameter. Okay, so let us take AC to be x, BC to be y, and this AO equal to radius of the circle. So that means this hypotenuse will be 2 times r. Now it's already given that area of this right angle triangle is S. So S will be equal to half into base into height. So I can write x into y. That means y will be 2x upon x. Now we are talking about least area, okay, the minimum area of the circle. So I have to write the expression for area of circle. So area of circle is given by pi r. It is given by pi r square. Okay, but here what we have to do is, we have been told that area of this triangle is fixed, that is S. So I have to make use of this, okay, when I'm writing the expression for the area of circle. So but here area of circle is what? Pi r square. So that means I'm supposed to write r in terms of either x or y. So let's see how we can write. Here if you see, r is the radius and this AB is the hypotenuse. So by Pythagoras theorem, okay, by Pythagoras theorem, x square plus y square equal to 2r square. Okay, so we get r square equal to x square plus y square upon 4. Now in place of y I can write 2s upon x. Yes, so I got x square upon 4 plus s square upon x square. Yes, so now let area of the circumcircle be A, then A equal to pi r square. So in place of r square I can write this x square upon 4 plus s square upon x square. So replace it, then you get expression for area in terms of x and s, okay, the given fixed area. Now differentiate this and you get this pi times in bracket 2x upon 4 minus 2s square upon x cube. Find the second derivative also, okay, and later on you can put this first derivative equal to 0 and then you can find the second derivative. So second derivative is coming pi times 2 upon 4 plus 6 into s square upon x to the power 4. So next, for maximum and minimum, the first derivative should be equal to 0. So put this first derivative equal to 0. Solve for x, and value of x you get square root of 2s. Okay. Now find the second derivative for x equal to square root of 2s, and there you get 2 pi. Okay, which is greater than 0. Hence area will be minimum, okay, when x is equal to square root of 2s. Okay, so s you got square root of 2s. Okay, so this is the point of minimum. Okay, or you can say that area will be least when x is equal to this. Okay, now you can find the value of y. Okay, and y is what? 2s upon x. Put the value of x and you get a square root of 2s. So you can see that x and y are same. And next, here it says r square. Okay, so we have to find the hypotenuse also, and hypotenuse is what? 2r. Okay, or you can use the Pythagoras theorem. Okay, and you can write that your r square will be 2r square will be x square plus y square. But anyway, here we can use this also. So r square is equal to x square plus y square upon 4, and there you get r square equal to s. That means value of r is square root of s. So 2r will be 2 times the square root of s. So this is the hypotenuse. So that's how you get the sides of your triangle. Okay, and here if you observe that here x and y, okay, they are equal. That means what? This triangle is nothing but an isosceles triangle. This is nothing but an isosceles triangle. So here in this question they can also write that ABC is a right angle triangle whose area is fixed. Okay, and then show that the circumscribed circle will have minimum area when ABC is an isosceles triangle. Okay, okay, now next question number 20. Here question number 20 says that the sum of 3 positive numbers is 26. So there are 3 numbers, let's say x, y, z, and their sum is 26. And it's saying that the second number is thrice as large as the first one. Okay, that means if second I'm taking y, okay, then that y will be 3 times the first one. Okay, if the sum of the squares of these numbers is least, find the numbers. Okay, so here they are saying that when you take the sum of the squares, then that sum will be least. Okay, so that means I have to write the expression. Okay, I have to write the expression of the sum of their squares in a single variable. Okay, so let us see the question's solution. So here I'm taking the numbers to be x, y, z. According to question, the sum is 26, and further they are saying that the second number, here second number is y, second number is 3 times the first one, so y equal to 3x. Okay, so from equation 1, okay, from equation 1 you get x plus 3x plus z is equal to 26. That means z will be 26 minus 4x. Okay, and next, sum of their square should be least. Okay, so sum of their square will be written as x square plus y square plus z square. Since we are talking about least, okay, so I need to have this expression in a single variable. So either you write it whole in terms of z or y or x. So here we'll write in terms of x. So x square, let it be as it is. Y can be written as 3x, so it becomes 9x square. Z can be written as 26 minus 4x, so we can write 26 minus 4x whole square. Simplify this, you get s is equal to 26x square minus 8 into 26x plus 26 whole square. Now find the first derivative, so you get this. Okay, then find the second derivative. Second derivative is coming a constant which is greater than 0. So clearly your s will be minimum, but for what? For which value of x, that we have to find by putting this d of first derivative equal to 0. So first derivative equal to 0, so you get x equal to 4. Okay, and second derivative is for x equal to 4, obviously is coming greater than 0. So the sum of the squares will be minimum when x is equal to 4. So once you know x equal to 4, then you can find your y and z. So y will be 3x, that means 12. Z will be 26 minus 4x, that means 10. So the numbers are 4, 12 and 10. Next question is question number 21. Here it says that a box is to be constructed from a square metal sheet of side 60 centimeters. So you have got a metal sheet of side 60 centimeters. So it's a square, okay, square metal sheet of side 60 centimeter, and you have to construct box out of this by cutting out identical squares from the four corners and turning up the sides. Find the length of the side of the square to be cut out so that the box has maximum volume. Okay, so here initially you have got square metal sheet of side 60 centimeter. Done. Now what you have to do is from each corner, okay, you have to cut identical square, okay, and then you have to turn those sides and make a box, okay. And they are asking that what should be the dimension of that square that you are going to cut so that the resulting box should have maximum volume, okay. So let us assume that the the side of those squares is x centimeter, okay. That means from each corner we are cutting a square whose side is x. Done. So after once it's cut, okay, you will get something like this. Done. Now this all this side has to be turned, okay, so that you can get a box. So you can see that if you cut from each corner, if you cut a square of side x, then here this length, okay, if you talk about this length, then this will be 60 minus 2x, because here actually total length was 60, so you are subtracting from this side x is subtracted, from here x is subtracted, that means 60 minus 2x. Same way here 60 minus 2x, 60 minus 2x, 60 minus 2x, okay, and this portion, okay, this will be x. So when you turn this, okay, this will be height, so height will be x, okay. So suppose from each corner a square of side x centimeter is cut, then for the box formed, okay, we have, so the box which will be formed, for that will have length 60 minus 2x centimeter, okay. So here also 60 minus 2x, here also 60 minus 2x, so length and breadth both you will get 60 minus 2x, and height, this portion will be turned, okay, so this will act as height, so height will be x centimeter. Now let us denote volume by V, okay. Then volume of that resulting box will be this 60 minus 2x into 60 minus 2x into x, that means length into breadth into height. So here you get 60 minus 2x whole square into x. So using a minus b whole square formula, you get this into x. So simplify, you get 4x cube minus 240x square plus 3600x, okay. Now you got this expression for volume in terms of single variable, so differentiate it. So you get the first derivative, okay, and you get first derivative over here, and this is your second derivative. For maximum and minimum value, first derivative should be equal to 0. So put this equal to 0, find the value of x. So here you will get two values, okay, of x. So x equal to 10 and x equal to 30. Now what we'll do, we'll find the second derivative for x equal to 10 first. So here I can see for x equal to 10, the second derivative is less than 0. Okay, that means for x equal to 10, okay, this volume will be maximum. So if you cut a square from each corner whose side is 10 centimeter, then in that case volume of the resulting box will be maximum. So at x equal to 10 centimeter, volume is maximum. When you find the second derivative for x equal to 30, in that case this second derivative is coming greater than 0, that means volume will be minimum, okay, when x equal when side of each square is 30 centimeter, okay. So here answer is x equal to 30 centimeter. That means from each corner one should cut a square whose side is 10 centimeter in order to get a box whose volume is maximum. Next question is question number 13. 13b. Here question says a wire of length 20 meter. Okay, there is a wire of length 20 meter that has to be used to fence off a flower bed in the form of a sector of a circle. Okay, what must be the radius of the circle if we wish to have a flower bed with the greatest possible area? Okay, so here there is a wire of length 20 meter and there is one person who wants to do the fencing of the flower bed, okay, in the form of a sector of a circle. So the question is, what should be the radius of that sector, radius of the circle whose part will be that sector? Okay, obviously that sector will be part of a circle. Okay, so what should be the radius of that circle? Okay, so that that sector could cover maximum area. Okay, so here we have got wire of length 20 meter. The same wire has to be put in this form. Okay, clearly this is a sector of, okay, of a circle. Sector means this will be equal to the radius of the circle, this will be equal to the radius of the circle. Okay, and this is the arc. Okay, so when you take sum of this r and this arc, okay, length of the arc, then total should be 20 meter. Okay, so that person is going to put the fencing in this shape. Okay, in shape of a sector of a circle. Okay, and this sector is a part of this sector is of this circle. Okay, so here we are looking for we have to find what should be the radius so that this area, okay, area of this sector should be maximum. Okay, so here we are talking about the area of the sector. Okay, and that should be maximum. So we need to write the expression of area of the sector, okay, in terms of a single variable. Okay, so and here one thing is known to us, that this perimeter, okay, that means the sum of boundary, okay, the length of the boundary is 20 meter. Okay, so according to question, r plus s, here s is length of the arc. Okay, so r plus s is 20 meter. That means 2r plus theta is equal to 20, because here if this is theta, okay, then length of the arc is theta into r. Okay, so we got theta into r is equal to 20 minus 2r. Okay, but here we are talking about maximum area of this sector, so I have to write the expression for the area in terms of a single variable. Next, let area of the sector equal to A, and we know that in class 11 we have done that area of sector is given by half into theta into r square, where theta is in radian. So here we have assumed that theta is in radian. Okay, so here what right now, if you see, this formula involves two variables, theta and r. Theta is not known to us, r is not known to us. Okay, so from equation, from this equation, okay, from this equation, theta r, okay, because this theta r square can be written theta r into r. So theta r, from this expression we can write 20 minus 2r. Okay, so here now you can see that area is written in terms of r only. Okay, so now differentiate this with respect to r, so you get 10 minus 2r. Again differentiate, you get minus 2. Now for maximum or minimum, this first derivative should be equal to 0, so you get r equal to 5. Okay, so now second derivative for r equal to 5, you get minus 2, which is less than 0. So therefore area will be maximum when r is equal to 5. That means area will be maximum when r is equal to 5 meter. Okay, so radius of the circle, okay, should be 5 meter. Okay, so this question is done. Next question is question number 15. So here question number 15. A rectangle is inscribed in a semicircle of radius r with one of its sides on the diameter of the semicircle. So there is a semicircle whose radius is r. So here r is fixed for us. Okay, and in that semicircle we have got a rectangle. Okay, and one of its sides, so one of side of the rectangle is on the diameter of the semicircle. So find the dimensions of the rectangle so that its area is maximum. Find also this area. Okay, so here we have to find length and breadth of that rectangle, okay, such that its area is maximum. Okay, and we also need to find the area. So here this is the semicircle. Okay, inside the semicircle we have got a rectangle. Okay, and one of its side is on the diameter. So here AD is on its diameter. Okay, now what we are doing is, here you can see that let us, already in this question is saying that radius of the semicircle is r. So here radius I have taken r. Okay, now I have to find dimension of this rectangle, okay, such that the area is maximum. So that means I have to write the expression, I have to write the expression for the area of this rectangle in terms of a single variable. Okay, now like this, here you can see that this rectangle. Okay, so here A, the corners A and D, these two corners are on the diameter and the other two corners are on the circle. Yes, so when I'll join this center and C, okay, when I join this center and C, so in that case OC is nothing but radius. Yes, and an angle will be made, okay, between OC and OD. So let that angle be theta. Okay, so and you also know that each angle of a rectangle is 90. That means D is 90. Yes, so you can see that we have got a right angle triangle ODC. Yes, ODC is a right angle triangle. So that means OD is nothing but OD is r cos theta. Okay, and CD is r sin theta. Okay, where r is constant. Okay, because already they have said in the question that r is given. Okay, so r is constant, theta is variable for us. Okay, so OD will be r cos theta and CD will be r sin theta, because you can see ODC is a right angle triangle. Okay, so now given r is the radius of the semicircle with center O, let us join OC. So OC is joined, then angle COD theta. Okay, let us consider, let us name it, okay, theta. Then CD will be r sin theta and OD will be r cos theta. Okay, so if you have a bit confusion how this CD became r sin theta, so you can write, you know that this is perpendicular, this is hypotenuse, so perpendicular upon hypotenuse will be sin theta. Okay, so your perpendicular is what? CD. So CD upon r is equal to sin theta, so CD is equal to r sin theta. So we got CD and OD. Okay, so CD is actually breadth and length of this is actually AD, but here we have found OD only. So AD will be what? AD will be 2 times OD. Yes. So your AD will be 2 times OD, that means 2R cos theta. Now area of ABCD, the rectangle ABCD will be A, and that A will be length into breadth. So here R sin theta into 2R cos theta. So it becomes R square, okay, 2 sin theta into cos theta. In class 11 you have learned that 2 sin theta into cos theta is nothing but sin 2 theta. Okay, so I got area in terms of a single variable here. That single variable is theta. Okay, because R is given to us, theta is not known to us, it could be anything. So we got the expression of area of rectangle in terms of single variable. Differentiate this with respect to theta. Okay, so you get here R square is a constant, so it comes out. Okay, so d sine 2 theta upon d theta. Okay, you simplify this, so you get 2R square into cos 2 theta. Find the second derivative also. Second derivative will be 4R square in bracket minus sine 2 theta. Okay, and you know that for maximum or minimum the first derivative is equal to 0. So put that equal to 0. So you get theta equal to, you get 2R square cos 2 theta equal to 0. So this 2 into R square cannot be 0. So okay, so that means cos 2 theta is equal to 0. Cos 2 theta equal to 0, that means I can write cos pi by 2. That means 2 theta is equal to pi by 2. That means theta is equal to pi by 4. Okay, that means 45 degree. Now we will find the second derivative at theta equal to pi by 4. So in this second derivative, wherever you have theta, replace that by pi by 4. Okay, so here when you are copying, I have missed out. Okay, this should be pi upon 4. Okay, so please, when you are copying it, okay, correct this. Okay, so that after that 2 into pi upon 4, that means pi upon 2, that would come sine 90 means 1, so it will come minus 1, that would be minus 4R square less than 0. Okay, so that means this area is maximum when theta is pi by 4. Okay, so area is maximum when theta is pi by 4. So the sides will be given as CD. R sin theta means R into sin pi by 4. That means R times R into root 2 upon 2. And AD will be R cos theta. Okay, that means 2 times R into cos pi by 4. R into root 2. Okay, and area will be AD into CD. Okay, and that would be R square. Clear? Next question is question number 19.2. Question 19.2. Here it says that show that the semi-vertical angle of a right circular cone of maximum volume and of given slant height is tan inverse root 2. So here we have got a cone. Okay, and when you join this vertex and this center of this base, so this angle made between this axis, okay, and this slant height is called semi-vertical angle. So let this be theta. Here L, slant height, is given to us. Okay, that means it is constant. Now H and R, okay, is not known to us. Okay, so here in this question it says that we have to show that semi-vertical angle of the right circular cone of maximum volume. Okay, so here we are talking about maximum volume of cone. Okay, so that means I have to write the expression for volume in terms of a single variable. Okay, and we know that volume of cone is given by 1 upon 3 into pi r square h. Okay, so let us see. Let theta be the semi-vertical angle. Okay, L is given to us. We have to show that theta equal to tan inverse root 2 when the volume is maximum. So write expression of volume in terms of theta. Okay, so V equal to 1 by 3 pi r square h. So what we can do is, here this r is the radius, this is h is the height. Okay, L is given to us. This is theta. So this h can be written as, if you see, this is a right angle triangle. Here this is base, this is perpendicular, this is hypotenuse. So this h is nothing but L cos theta. Okay, and r is nothing but it is L sin theta. Okay, so here from that figure you can make out that r is L sin theta and h is L cos theta. So in this equation 1 we can put these values. Okay, so we'll get V equal to 1 by 3 into pi L square sin square theta into L cos theta. Okay, and simplify this, you get V equal to 1 by 3 pi L cube cos theta into sin square theta. You can see that 1 by 3 pi L cube is nothing but a constant value. Okay, so in place of this I can write k. Okay, so I got V equal to k times cos theta into sin square theta. Now find the first derivative. Okay, and you get k times this. Then find the second derivative. That means you have to differentiate this again. So simplify and you get this. Okay, second derivative. Now you know that for maximum or minimum, the first derivative should be equal to 0. So put that equal to 0. Okay, from here you can see that sin theta is common, so sin theta comes out common. So either sin theta equal to 0 or this equal to 0. But sin theta cannot be 0 because sin theta equal to 0 implies theta equal to 0. Okay, that means this would become 0. That means this L and this H will overlap. So in that case, we will not have a cone. Okay, so that theta cannot be 0. Okay, so this part will be equal to 0. So simplify this. Okay, so when you simplify, you get tan theta equal to root 2. So theta will be equal to tan inverse root 2. Okay, and this theta will be positive. Why? Because you can see that this theta is nothing but it's an angle in a right angle triangle. Okay, so this is 90. Okay, so obviously this has to be greater than 0 and less than 90. So that's why this theta, okay, is positive. Okay, now what we'll do is we'll find the second derivative for theta equal to tan inverse root 2. Okay, so our second derivative is this. Yes, so cos cube theta into k times in bracket 2 minus 7 into 2. Okay, because here we have got tan square theta, so in place of tan square theta straight we can put 2, so that's why 2. And so I got 2 minus 14, that means minus 12, and here in place of theta we have to write tan inverse root 2. Okay, since theta is positive, so this cos cube theta will be also positive, so that means I'm getting minus 12 into k into something positive. Yes, so it will be less than 0, so it implies that volume will be maximum when theta is equal to tan inverse root 2. Okay, so now last question, show that of all the rectangles inscribed in a given fixed circle, the square has a maximum area. So here the question is, in a fixed circle, okay, so if you have been given a circle, okay, of a fixed radius, so in that case if you draw a rectangle, okay, if you draw a rectangle of maximum area, then that rectangle will be a square. Okay, so here we are talking about maximum area of a rectangle. Okay, so we have to write the area of rectangle in terms of a single variable. Okay, so here ABCD is a rectangle. Okay, ABCD is a rectangle inscribed in this fixed given circle. Now that means radius r is fixed, constant. Okay, so here radius is r and this is the rectangle. Okay, and you know that rectangle, each angle is 90 degree. So that means when you join this A and C, okay, A and C, that is AC will be nothing but the diameter. Okay, it will be diameter. So area of this rectangle will be what? AB into BC. Okay, so I should know the value of AB and BC. Okay, and plus I have to write the area in terms of a single variable. Okay, so here r is fixed. Okay, theta is variable for us, so we will try to write AB in terms of theta and BC in terms of theta. So here ABC is a right angle triangle, so this AB is nothing but 2r cos theta and BC is nothing but 2r sin theta. Yes, so AB is 2r cos theta and BC is 2r sin theta. So area of this rectangle will be AB into BC. That means 2r cos theta into 2r sin theta. That means 2r square into 2 sin theta into cos theta. So I get 2r square into sin 2 theta. So I got area in terms of a single variable. Okay, here r is constant. So find the first derivative. You get 4r square into cos 2 theta. Then find the second derivative. You get minus 8r square into sin 2 theta. Then for maximum and minimum, the first derivative should be equal to 0. Okay, so put equal to 0. Simplify. Okay, then you get theta equal to pi by 4. Now find the second derivative for theta equal to pi by 4. Okay, and you get minus 8r square, which is less than 0. That means area will be maximum when theta is equal to pi by 4. So area is maximum when theta is pi by 4. So what should be the AB? So AB should be 2r cos theta. Put the value of theta and you get r times r into root 2. Okay, and BC you also get r into root 2, that is equal to AB. So here you can see that your BC and AB are same. That means that rectangle is nothing but a square. Okay, so this is all. Okay, and this chapter gets over. Okay, here somewhere I told you to make correction. Okay, so here in this case, okay, when you are writing here, actually I was supposed to write 4. Okay, so when you're copying it, please write pi by 4. Okay, then it will become pi by 2. So this is all, and this chapter gets over.